drugs, or ideas, what you consume influences who you become. On the Mind and Matter podcast, we learn together from the best scientists and thinkers alive today about how your mind-body reacts to what you feed it. Before starting Mind and Matter, I spent 10 years in academia doing scientific research. I got a PhD in neuroscience where I focused on neuroendocrinology and the neurobiology of behavior, and before that, I specialized in molecular, developmental, and evolutionary genetics. I use my scientific background to help parse and translate the information that guests share on the podcast. In addition to the podcast, I write long-form written content inspired by the show where I integrate what I've learned across episodes. I also have a free weekly newsletter where I provide you with upcoming guests, share links, and provide commentary on scientific studies and research that I'm reading, and more. Visit mindandmatter.substack.com to find all of my content. Parker, welcome back. I just had you on the podcast. That one's actually doing really well. People, I mean, it's quite a trip what we talked about. We talked about parasites and the microbiome and stuff, but we wanted to do this podcast because the topic is quite a bit different. You also have expertise here, but we decided to make it a whole different standalone podcast, and I think that was probably the right call. Do you want to just remind everyone, because some people will be listening that didn't listen to the last episode that we did, who are you and what's your background?
Well, my name is William Parker, and thank you first and foremost for having me here. It's a pleasure to be back. I was a professor at Duke University for years. I worked there for almost 30 years. I think we didn't talk about this last time. I am the village blacksmith, so I have a blacksmith shop and do a lot of research on underlying causes of chronic conditions, which is something that, of course, you and your audience are I've seen some of your podcasts, and when somebody comes in there saying something fishy, well, you have to do exactly this to solve this big problem, and you know it's fishy. I've seen you can tell what's fishy and what's not. Very impressive. So that's what we work on, is what's the underlying cause of disease. We were very blessed and figured out the function of the human vermiform appendix, which is something Leonardo da Vinci worked on. And we were the first to look at immune function in wild animals. We were the first to predict that COVID-19 would not be that detrimental clinically in low-income countries because of how their immune systems work. And so, of course, we have done work on autism as well. We started more than a decade ago, back around 2007, and the field has changed a lot since then. And we've learned a lot since then. It is a chronic inflammatory condition in many individuals with autism, not in all, which is how we got interested in it to start with.
Mm-hmm. So I'm going to read just a sentence here from one of these papers to give people a sense for where we're going. And it might take us a little bit of time to get there because I want to give people some background on different things. And when I say different things, we're going to talk about autism, and we're going to talk about things like Tylenol, things that in most people's minds have no connection. And so I want to make sure people have the right background concepts before we allow you to make your arguments here. But here's the excerpt. You say you and your co-authors that there is overwhelming evidence to show that exposure of susceptible babies and children to acetaminophen triggers many, if not most, cases of autism spectrum disorder, and that oxidative stress causes susceptibility. Right. So that's where we're going to go. Let's start with autism and give people a sense of what we are talking about. So can you just define autism for us, both in terms of how you define it individually and how that term is being used in the zeitgeist today? What is autism?
Right. So autism is a spectrum disorder. Autism spectrum disorder is the official term. It's very similar to fetal alcohol spectrum disorder. It's the diagnosis varies from individual to individual. I am a scientist by training, biophysics, biochemistry, immunology. I worked with neuroscientists. I work with professional industry pharmacologists and toxicologists. So we don't use any definition other than the clinical definition, which there's three basic criteria, right? One has to do with of course, the social problems, the difficulty in understanding social situations. And that's also true in Asperger's syndrome. And with Asperger's, that's maybe the featured characteristic. And Steve Edelson, who's the head of the Autism Research Institute. He's the oldest research institute around, and wrote a beautiful paper and just in 2022 published in a journal called Genetics, just talking about how Asperger's is probably on the spectrum with autism spectrum disorder, but it's defined different clinically.
Mm-hmm.
So, but it's probably, and we'll go into this, probably induced by the same combination of ingredients.
The same forces.
Yeah, same thing that causes autism spectrum disorder. So that's one, is the social awareness. It's a hallmark across the board. And then you've got aversion to new stimuli, and you've got repetitive motion. So and a lot of the people with autism, that tends to be a hallmark of autism, but less well known. It's part of the clinical definition, but less well known than the difficulty with social awareness. And of course, as most people now know, maybe a quarter to a third of people with autism are severely affected. A quarter will never learn to go to the bathroom. Many of them are nonverbal, where, it's a spectrum. And then you've got highly functional individuals with autism that you wouldn't even really know they had autism just with superficial interactions, because they've learned how to interact socially. Even though they don't understand social interactions, they can memorize enough information to get by superficially in social interactions. But then, of course, when you get to know them, you will begin to see that.
Yeah, it's like in the movies. Like, there's movies where aliens are inhabiting a human body and they're like pretending to be humans. It's kind of, they can kind of figure it out, but then once you dig deep enough, you're like, wait a minute, you're different.
Right, and that's just it. You can tell they're different, and of course, those people can live full normal lives, whereas someone who can never learn to go to the bathroom, they cannot. So it's a spectrum,
right?
And we'll get to what causes that spectrum in a bit, as you said. And I hasten to point out that this is not very complicated. It's going to be fairly easy for everyone to understand. Mm-hmm. And the harder question is, how did this happen? It's going to be, and we'll see if everyone agrees, but I think that's going to be the long and short of it.
Right. So there's a spectrum of symptoms or phenotypes that are displayed by people that fall within this umbrella of autism spectrum disorders. It can be very severe. It can be mildly severe. It can be somewhere in the middle. It's a spectrum. There's variation. That actually tells us something, I think, about, the pathophysiology or the types of things that could be causing this. And we'll come to that. But you said there's distinct clinical criteria. So one of them is this social deficit. And what were the other ones?
Right. And then there's the repetitive behaviors.
Okay.
And then there's the aversion to new stimuli.
Yeah. Aversion to new stimuli, repetitive behaviors, and social interaction deficits. So something about the nervous system is different, such that it tends to give you those things in people with autism spectrum disorders. The exact way that manifests, the exact combination and severity of each of the types of things in those categories is different from individual to individual with this autism spectrum disorder. How has autism changed over time? So, big picture here, we know that the rates of autism have gone up wildly over the last few decades. And so the question is, to what extent is that representing a shift in diagnostic criteria and people are just getting looser with what they diagnose versus a genuine increase in whatever this neurodevelopmental abnormality actually is?
Well, let me hasten to say I'm not a clinician. The people that do the official diagnosis, I mean, it can be complicated, and there's sub-criteria, and there's other things that the clinicians look at. But the bottom line is that the criteria we have today are very similar to the criteria they had in 1943 when Leo Kanner published his work in the United States, and which are very similar to, there was a Soviet clinician back in the 1920s that published a description of autism, extremely similar. But what we hypothesize is that if you could it's a thought experiment, right? It's not a real experiment, but if you could go back in time and grab Leo Kanner out of the 1940s and bring him into today and say, can you diagnose this group of individuals? He would probably miss about maybe half of, he would probably not get the severe cases today. And what we think is going on is that you've got a real increase in what we call prevalence. And that has led to more awareness, just paying attention, just a change in medical attitudes, change in parents' attitudes of in 1943, if maybe they were only catching very severe to mildly severe cases, but probably not the very, very mild cases.
So there's probably there's probably a genuine interaction here between the fact that if something becomes more prevalent, genuinely more prevalent, more people are then aware of it, and therefore we're more sensitive to see it. And so both of those forces combine to give us more of it.
Absolutely, and there's no question that's going to happen. If it's super rare, you're just looking at severe cases, and then you can see more of the full spectrum when you get. And of course, Asperger was working at the same time. He was working in Nazi Germany at the same time Connor was working here. So he described sort of what we're talking about is it's not even sometimes questionable whether it's on the spectrum or not. I think in terms of the neuroscience,
right? So Asperger's is effectively mild autism.
It's a type of autism. Yeah, I mean, some Asperger's can be fairly pronounced in terms of lack of social awareness, and can create incredible difficulties. I think the bottom line is that they had some awareness of a spectrum in 1940, but probably not as much awareness of the milder end of the spectrum as we do today.
Got it. Okay, so it's become more prevalent over time. That is probably a combination of a genuine increase in prevalence of this spectrum of neurodevelopmental abnormalities combined with increased awareness and sensitivity to actually see it and detect it in people. There's lots of ideas out there and lots of controversy about what causes autism. Let's start with, if you were to just start plucking mainstream scientists out of labs at big universities that study autism, broadly speaking, what would the mainstream scientific views on the most plausible likely causes of autism be today? How would you describe those?
So I think virtually 100% of the mainstream view is, so if you pooled 100 people that are in a university system, what causes autism, you would get 100 answers that would all essentially be the same. Some people would say it's more genetics, and some people would say it's a combination of genetics, environment, and epigenetics. Just a mixed bag of things that come together that in a way that we don't understand, in a very complex, and the word complex is frequently used, complex way to cause autism. So that is absolutely, and ironically, that is confusion between association and causation. The widely held theory is a classic example of confusion between association and causation, but that is the current theory.
And so there's lots of this is a controversial topic, right? This gets into all things like vaccines and conspiracy theories around environmental causes of autism. Before we get into what you think and the evidence that we're going to go through around some of this stuff, why do you think this is such a controversial topic? Why do you think there's such a wide range of beliefs out there, both in the scientific and outside the scientific communities? And why can't people seem to agree on how to reason about this?
Well, so we have done a lot of work looking at the answer to that question, exactly the answer to that question. So, and the answer is, it's complicated. It's easier to think about the answer to your question if you know actually what induces autism. So to try to answer that question without giving away what induces autism, so the induction of autism is not usually tied directly. Sometimes it is, and these are important cases, but it's not usually tied directly to the observation of autism, because autism, we now know maybe half of all cases are induced right around the time of birth, and you don't see it until years later. So you don't normally connect the dots there.
There's a separation between when the symptoms become clear and we diagnose it and what the triggering event or important event was, because that happened before.
There frequently is. Now, if you look at that, that's not always the case. So there's something called regressive autism, and a lot of parents in the past, and parents' observations have never been wrong historically. And there's repeated, the parents said, "Hey, my kid is regressing," and modern science took until 2005 to actually sort that out and accept that. So incredible delays between parents' observations being reported versus modern science just accepting the parents' observation. So a lot of the parents were reporting, "Hey, my kid got vaccinated and regressed to autism. And so we now understand why that observation happens based on a study done in 2008, beautiful study. But it's, if the parents are not easy to gaslight, right? If they saw what they saw, and they'd already had this experience of being told, no, it can't be regressive because they're born with it. So that's, they had a history of this kind of
I see. So
bad interactions,
yeah,
essentially, with mainstream medicine.
yeah. So probably part of the reason why this is such a controversial issue and people get into heated disagreements about this is because historically there has been a discordance between what parents observe and report and then what's accepted as being plausible by, the physicians or the researchers they might be talking to. And then it takes time for those things to get sorted out.
Yeah, and it's even worse than what I've mentioned. When they first figured this out in the 1940s in the U.S. and in Europe, they came up with a model called the refrigerator mother hypothesis, which is this horrible model which blames autism on the parents being aloof. So that refrigerator mother hypothesis held sway from the 1940s until 1965.
What is that? So, where does that term come? What exactly does that mean, refrigerator mother?
Refrigerator mother. It's a cold parent. They're aloof. They're not
I see.
Really,
Okay.
Yeah. I mean, there's some horrible. There was a quote in the New York Times that the parents just thought out just enough to make a baby, and then that was it. So, and that's by Leo Kanner, who discovered described it a second time, and again, it had been described in the 1920s. So it's just, so there's a bad history between parents and mainstream medicine that goes back essentially to the beginning of our understanding of autism in the Western world.
And to what extent, can you just comment a little bit about to what extent is autism linked to carrying specific genetic mutations?
Well, so there's something called hidden heritability. I don't know if your group has ever talked about that, but this is a classic example of that, where if you look at familial associations, you'll see, wow, okay, autism looks inherited, but then if you try to find the genes that are responsible, they're all over the place. There's hundreds of genes, so you can't identify. If you look at families, you look at identical twins, you look at discordant twins, you look at siblings, say, well, this is definitely inherited, but then the genes don't exist. Which if you understand what causes it, then you understand why that is. But
I see. So we'll come to that, but it certainly looks like it's inherited because you see it, if your twin has it, you're more likely to have it. If it's in your family, you're more likely to have it. But when people then go in and look at these families and they look under the hood and they look at the genes, it's not been obvious what the genes were and how this works.
Right. So a lot of genes related to immunology, oxidative stress. Some of them are related to the autophagy system, which is how you repair injury. And again, that all makes sense if you know what causes it.
Got it. Okay, so how did you get into this particular question and this particular subfield?
Well, we were renowned at Duke University for having figured out that the immune system is supporting your gut bacteria. Up until then, everybody believes your immune system was at war with your bacteria. And we were the first to describe what we call biofilms, as we talked about last time. And then it turns out that in the autism research community, people were starting to look at biofilms in the gut, because kids with autism tend to have 60% roughly, depending on which number you look at, tend to have problems with their gastrointestinal system. So I basically was contacted by people that were working in the field of autism, and they said, hey, you should really look at this. This is related to your work. And this was before I had a clue, and before anybody had a clue about what was really inducing autism. So we were just sort of looking at downstream things.
So we've known for a while that it sounds like the majority of people with autism have gut issues of some kind, but no one really knew with what that connection was for a long time.
Well, I mean, right. I mean, if you don't know what causes something, then it's hard to connect all the dots. That's a beautiful thing in science, right? Is when something actually clicks, something makes sense. It's like, oh, okay, now then you get a bunch of things falling into place.
Right. Your perspective shifts, and now you can connect the 10 dots that seemed independent before.
Correct. Yeah.
Okay, so how did this start? So you get into this field. How did just can you just kind of describe the history here in terms of what did you guys start to look at and discover for the dots to click in the way that they have clicked in your mind?
So we were interested in something called biota alteration or biome depletion, which we talked about in last time. So we know that everybody in the West is more prone to get chronic inflammatory conditions, and we knew autism was in many individuals, but not all, related to chronic inflammation. So we were really looking at how chronic inflammation and how biota alteration affected the brain. It was incredibly productive research and led us, I think, to how to effectively treat major depressive disorder, which we're still working on applying that in the clinic. Today, I spend most of my time this week trying to figure out, how can we get a protocol approved through the FDA and get funding and run this trial. So that was really where we were at there. But there were some things about autism which did not make any sense. So first of all, the prevalence, it started in 1920, 1940, just being super rare as far as we could tell. And it really started shooting up in 1980. Mm-hmm. And then it took off in the 1990s. So that mm-hmm. was just not consistent with, inflammatory bowel disease or, say, appendicitis, other things that are associated with these chronic inflammation problems.
Yeah. So it sounds like, based on everything you've said so far, so autism or autism-like stuff was people were noticing it in the 20s, 30s, and 40s, but it was very rare back then. And it didn't really start to become much more prevalent until the 80s.
Well, technically, nobody noticed it in the 30s, but 20s, 40s, and then, after the 40s, then it's because basically the work in the Soviet Union was just forgotten. So it was rediscovered in the 40s, and then it sort of became it was a rare diagnosis, but most people had never heard of it. But some of the clinicians working in neuropsychiatric problems in pediatrics probably had. Most of them probably had, just because it was on their list of things to do. But for example, in the 60s, there was only one group that was even interested, one nonprofit organization, and none of the government's organizations were tracking it at that time.
Okay, so it becomes much more prominent in the 80s, and then it sounds like it sped up even more in the 90s.
Right, it sped up more in the 90s. It just kept going up and up. That's mm-hmm. the bottom line. Yeah.
Okay, so what comes next in the story of, in terms of how you were thinking about this and probing things?
Right, so a guy named Stephen Schultz, he was a dentist in Denver, Colorado. His kid was vaccinated and just regressed into autism, a classic case. And he quit his dentistry practice, went to the University of California and got his PhD doing a study trying to figure out, well, was it the vaccine, and let me hasten to point out, there were some other studies done early on in the 90s, which just said if you don't vaccinate your kid, and the kid can still get autism. And those were extremely clear. The statistics on those were off the charts. So everybody knew it wasn't a vaccine, but Dr. Schultz saw what he saw. Mm-hmm. So he went to the University of California and got his PhD doing a survey study saying, well, was it something you gave with the vaccination? Mm-hmm. And it turned out that when you zeroed in on it, it was acetaminophen, and he found the 20-fold increased risk of regressive autism with acetaminophen use between 12 and 18 months. So that's sort of, if you look at the way the study's done, it's not a huge study. The p-values aren't great, but 20-fold is a lot. And of course, right. We're supposed to be cautious about. Okay. So, and the thing is, though, if you were in 2008 and you really start looking at, and we've done this, we said what information was available in 2008, then all of a sudden your eyes get really big. Like, wow, there's a lot of information available in 2008, which tells us this drug is not safe. But to put this in context, a neonatal laboratory animal was never exposed to acetaminophen until 2014 for the purpose of testing neurodevelopment. Never until 2014. 24.
Okay, so hold on, because that's an amazing stat right there. So acetaminophen never exposed An animal, prenatal animal was never exposed to acetaminophen until 2014, which
Well,
means
this
we
is a
had
perinatal, so they would be
perinatal.
between 1 and 10 days age. Yeah,
Yeah.
I may have
So,
said prenatal, but it's perinatal.
but that's wild because that drug's been around for so long, but no one had ever looked at anything to do with development, and so we would have had no idea. Let's back up for a sec. What is acetaminophen? What are the other names it's known by that people might be familiar with? And let's talk a little bit about how this drug works at a basic level before we dive back into the autism story.
Right. So acetaminophen or N-acetyl para-aminophenol, or also known as paracetamol, also known as Calpol or Tylenol, or depends on, in Italy it's known as paracetamolo, and they know what tacopurina is, but they don't know anything else. So every country has its own name, which makes it tough if you're a parent and you're in a country which has a different name, because the literature doesn't use the name that you use.
Right,
So
right,
bottom
right. So
line is,
we're talking about Tylenol, and I think we'll probably use the term acetaminophen, but it's the pain drug that you can buy at the store that everyone has probably
yeah,
encountered at some point.
yeah, pain and fevers, those are two main indications. Um, yeah, and it's not just in, people are surprised to find out, oh, it's in Mucinex, or it's in this, or it's in 400 different drug mixes in the United States.
Hmm. And how does the drug work at a basic level?
Oh, right. Yes, of course. How does the drug work? Well, the drug doesn't do anything by itself.
Mm-hmm.
So your body metabolizes the drug into different things. One of the key metabolite, it binds to something called arachidonic acid, gives you this acetaminophen metabolite 404, AM404, so-called. That's then becomes bioactive, and then it does a lot of different things. So it has effects on pain and on fever. So it's shutting down the function of the hypothalamus to produce fever. You say, and of course that's part of the brain. You say, well, shouldn't we have tested this on neurodevelopment? The answer is yes.
Right. If it's affecting fever by affecting the brain, then it could very well be doing other things to the brain.
Right, and it also interacts. So it shuts down the production of some of the really important lipids in the brain. By inhibiting an enzyme called COX-2 or cyclooxygenase 2.
Mm-hmm,
and
mm-hmm.
it also affects the endocannabinoid system.
Yeah,
Which,
yeah.
natural cannabinoids.
Yeah, so these COX enzymes, they're the things that process omega-6 polyunsaturated fatty acids into various other lipids that do all kinds of stuff. And it also affects the endocannabinoid system, which, for those who have followed the podcast for a while, I mean, that's going to affect all sorts of stuff in the brain and the body.
Right. Yeah. And we know that, acetaminophen affects social awareness in human adults, but we don't know how that works. It's so.
What do you mean? What?
Yeah. No, there's several studies. So an adult, when they take acetaminophen, they're going to feel temporarily sort of disconnected from their community. And, psychologists can measure this, right? Disconnected from the community, they're less sensitive to social outrage. That kind of
so this is just a side effect in adults who take it acutely.
In adults, it's a temporary side effect. Yeah.
Wow. So we know at the biochemical level and at the symptom level, obviously it's affecting stuff in the brain. Part of how it works to reduce fever is by affecting stuff in the brain, in the hypothalamus, that's responsible for fever. It sounds like acetaminophen isn't doing anything per se. It's metabolized, and if I'm hearing you correctly, is it metabolized into multiple things, and there's sort of like multiple metabolites that go and do separate stuff?
Oh yeah, there's so many. And the key to this drug is key to understanding what goes wrong is that it can get metabolized in a safe way where it just gets made water soluble and peed out or pooed out, which is called phase 2 metabolism, or it can go down a toxic pathway, which is phase 1 metabolism.
And what's the difference there? What's the toxic pathway?
Well, so the safe pathway is where you just stick something on the acetaminophen and make it more water soluble and it becomes inactive, and then it can be flushed out. The non-safe pathway, the phase 1 pathway, is where your body tries to burn it, which is a typical way. It's a cytochrome mediated process where you're trying to oxidize the molecule.
So cytochrome oxidase enzymes in the liver are trying to chemically metabolize this drug.
Yeah, and in adults, it's almost exclusively in the liver, but unfortunately, in the neonates, it's also in the brain,
Hmm.
where the liver's not really going very well for a newborn because their bodies aren't set up for that yet. They're only naturally getting exposed to breast milk, so they don't really need. They're not exposed to a lot of xenobiotics or
Oh, I see.
foreign.
It sounds like what you're saying is we have a whole family of enzymes called cytochrome oxidase enzymes. In a fully developed individual, in an adult, those are mostly in the liver. They're not only in the liver, but most of them are in the liver, which is why we think of drugs as being metabolized mostly in the liver. But in a neonate or in a very, very young individual who's not fully developed, that whole system in the liver is maybe not fully online yet. And so a higher proportion of the drug they're exposed to might get metabolized by enzymes elsewhere, such as in the brain.
Yeah, that's the first thing, and then the second thing is in the neonates, and this has been known in humans for a long time, that one of the safe pathways, there's two basic phase two safe pathways. One is called glucuronidation, and the glucuronidation pathway in babies just doesn't work. It's just
it's just
not
not online
performing.
yet.
It's not online yet. It takes a week or three to get it online, and ironically, every veterinarian knows that a domestic cat, Felis domesticus, cannot get acetaminophen because it's dangerous to them because they're deficient in glucuronidation.
Hmm.
So just nobody connected the dots
Hmm.
that, hey, we know that babies don't have glucuronidation. We know that these our domestic animals can't get acetaminophen if they don't have glucuronidation. So maybe, just maybe, this drug might not be the best for a baby. It was just never, they only check for liver function. And we know that you can kill a neonatal laboratory animal with acetaminophen without hurting its liver. That has
Hmm.
been demonstrated. You can give it so much acetaminophen that it dies, but the liver will be fine.
Wow. Okay, so metabolism changes as we develop. It takes time for some of these metabolic pathways and for the liver to fully mature and come online in a baby, in a very young animal. And so if you give drugs to an adult animal versus a juvenile or baby or even, developing animal in the womb, it's going to get processed very differently and it's going to end up doing very different things because all of the metabolism is different at all of these developmental stages.
That is correct, yes.
And I mean, when you say it out loud, it makes perfect sense. Like, well, of course, like it takes time for stuff to develop during development. That's the whole point. Things are being built, they're coming online. Therefore, things like drugs, like acetaminophen, will plausibly not be processed the same way in a developing animal as in a fully developed one.
Yeah. And
But
yeah, every clinician knows that a baby is not just a small adult. I mean, that's the
right,
classic statement of it. But unfortunately, when acetaminophen was approved, not by the FDA, but basically by a collection of physicians working with a pediatric association, they were only looking at liver function, which is with the underlying assumption that the babies are metabolizing in the same way that the adults are. And it's just a tragic mistake.
right. Yeah, just unexamined assumptions. So take us back to the history here. So we had that gentleman who was a dentist. He had a child. The child developed autism. He literally quit his job and got a PhD. And he saw some of the first evidence that maybe acetaminophen had something to do with this.
Right. So then if in 2008 you'd start looking around, and one guy did, his name is Peter Good, and he wrote a paper about this. He's looking at the bigger picture saying, hey, look, first of all, it's known that children with autism can't process acetaminophen very well. That paper had been published in the 90s,
Hmm.
but apparently no toxicologist to look at it. So remember I said there's two different phase two these safe pathways. One's glucuronidation. Babies just don't have it. The other is called sulfation. Well, it turns out, and this has been confirmed repeatedly, that babies or children with autism have very poor sulfation sort of pathways. They're not well, and it's genetic. It's there's a range of sulfation in humans, like there's a range of most other things, and some of them are very, very poor at it, and so that's going to mean,
They're
especially
more
when
sensitive.
yeah, they're going to be more sensitive. So
Yeah.
that it's yeah, the story is sort of the same as with codeine. I don't know if you know that story or not.
No.
It was so codeine was almost the same. It was you, of course, it's metabolized into morphine, but and used since the early 1800s. Even acetaminophen came in use 1886, codeine 32 or something like that, way back in the day, and it was just banned by the FDA in 2017 for children under 12. And the issue is that it gets metabolized into morphine, but different people metabolize it at different rates. So if your body happens to metabolize it too fast, it can kill you if you're a kid, because it's just respiratory suppression.
Right. You're
And
essentially
children don't
overdosing because
have
you're making a lot of it quickly.
exactly. It's just an overdose on morphine by taking codeine. So, that, and I think that not it wasn't it was less than 30 kids that were reported to have died from it, but still they just banned it. That was
Right,
it,
right.
because it's the right thing to do, even though it's a really effective drug for some people.
Wow. So they banned that because 30 kids died. So no more giving codeine to children under a certain
I
age.
think it was
And
24 to be exact reported, but they don't know how many didn't get reported, right? Because
right,
if your
right.
kid stops breathing, then especially because it's a fairly rare event, then you don't, it was given to 3 to 4% of the kids that were in the hospital at that time for, say, just coming to the emergency room.
Hmm.
So that's a lot of people getting codeine, and then
Hmm.
you have 24 documented deaths, but you don't know how many others there were.
Hmm.
So
Hmm. Hmm.
that was enough to cause them to ban it, and they did understand the biochemistry of it, just like we understand the biochemistry of acetaminophen. But the point is that most people were okay. It
Right,
depends on how you metabolize it.
right. Certain sensitive individuals who have an impairment or a difference in metabolism, in this case, sulfation type metabolism, they will be more sensitive to acetaminophen because there are multiple ways the body can metabolize it. Some result in toxic byproducts, some don't. So if you've got a deficit in the metabolic ability to non-toxically metabolize it, you're therefore going to mostly toxically metabolize it and then be more sensitive to the bad effects of the drug.
Yeah, there's 3 points of sensitivity, and we've talked about two, but yeah, that's basically it. So you've got, and there's a fourth point of sensitivity if you can't repair damage. So you've got all of these points of sensitivity, and if they add up to too much, you're going to get an injury that will be that'll be permanent,
Yeah,
unfortunately.
yeah. And this will start to make sense of, I hope, for people why, oftentimes when we talk about genetics and a genetic predisposition, right, it's usually not that you have a gene with a mutation and then like you get a disease, period, all or nothing. It's often that having a certain set of genetics will render you more sensitive to things like this, meaning your metabolism is a little bit different. You've got a little bit more of this side of it and a little bit less of that side of it. And therefore, if you're exposed to something at the right time of development and you have those predispositions, you will then be affected more by this thing that you may or may not be exposed to at a certain age. It depends on all of those things.
Yeah, and the corollary to that, which is really interesting, and this is something I say to educated audiences, is because some people get it. So imagine everyone was smoking a cigarette.
Mm-hmm.
The lung cancer would be very prevalent, but it would look genetic,
Right, right,
right? It would, because everybody's smoking. Then it's not about smoking whether you get lung cancer; it's about susceptibility.
right.
So Tylenol has essentially become that way. It's so everywhere that and plus with acetaminophen, there's an extra issue that if you're lacking in sulfation, you're lacking glucuronidation, and then there's another there's another pathway where you can detoxify stuff, and if you can't do that, that means you're probably sicker than most people.
Mm-hmm, mm-hmm.
So if you're sick, you tend to take more or receive more acetaminophen. So it's sort of a vicious
Right.
sort of back and forth loop, right? You get sick, you can't process it well, but you get sick, so you get more of it,
Yep.
because that's
So,
what
yeah.
people. And it's not the parents' fault, it's not the doctor's fault,
Right.
because they haven't been told this.
Right. So we've got multiple things at play here. So if you were to take acetaminophen, if you're still developing or fully developed, that's going to be processed by your body differently. On the metabolism side, you've got a couple different pathways that can metabolize acetaminophen without producing a toxic byproduct like sulfation, like that other pathway you talked about. There's then another way to metabolize acetaminophen that will produce a toxin, and we'll talk more about that. People can vary in sort of like the strength of each of those pathways, and therefore how much toxicity will be produced at a given stage of development if acetaminophen is taken. And then we've got this other piece that we'll probably come to, which is detox. Even if you produce the toxic byproduct, we all then vary in our ability to detox ourselves from those toxins.
That is correct, yes.
Got it. So let's talk about the metabolic pathway of acetaminophen that results in toxicity. Dig into that a little bit more and tell us, where is this happening? What is the cytochrome system, and what is the actual toxin that's produced, and what does it do?
Yeah, it's predominantly a cytochrome called 2E1, right? Cytochrome P450 2E1 predominantly, but there's other cytochromes that can do it. And what it does is it oxidizes the acetaminophen, removes hydrogen to produce a quinonamine. It's called NAPQI. You'll see it in the literature because it's N-acetyl paraquinonamine. So that's the one that basically, if your body has a way to neutralize that with a molecule called glutathione,
Mm-hmm.
but if you're sick, you might be depleted in glutathione.
Right,
So,
right.
or if you can't, I mean, in laboratory rats, glutathione depletion happens really quickly, so that just with skipping 2 meals for a laboratory rat will cause them
Right.
double the toxicity of
Yep.
acetaminophen.
So yeah, let's make sure people get this piece because it's important. So glutathione is a very powerful natural antioxidant, right? So when people they talk about vitamins and minerals and antioxidants, right? Antioxidants are supposed to be good for you because they're going to neutralize things that cause oxidative stress. Glutathione is a natural antioxidant, but you've only got so much at a given time. And so if you deplete your reservoir of glutathione, then you're going to be more prone to oxidative stress. So if you take something like acetaminophen and it turns into something like NAPQI, which can cause oxidative stress, most people will have glutathione at some level that can take care of that. But if you've run out because you're malnourished or you've got some kind of genetic abnormality that gives you lower glutathione reserves, then you'll be more sensitive to damage from that molecule.
Yeah, and probably one of the biggest things that gives people problems is an autoantibody that binds to the folate receptor. So,
Hmm.
and a guy named Richard Fry at Arkansas Children's Hospital Little Rock identified 72% of the kids with autism have this antibody which blocks the folate. And folate, without folate, you're not going to be able to form glutathione well. You're not going to be able to. There's a whole system that doesn't work very well, the
Hmm.
antioxidant
Hmm.
system, if you can't get folate on board. So that's possibly huge. And then so if you say, well, it's then related to autoimmunity, and you look at, then that's opens up a whole bunch of other genes, right? Which explains why so much genetic association with autism
Right.
and
There's multiple ways to be more sensitive to the toxic effects of acetaminophen. And the
yeah.
genes that are involved in those sensitivities tend to be exactly the ones that show up more in people with autism. It sounds like that's what's true.
Yeah, we published a paper in 2017 just looking at so many things associated with autism, and they're all tied in with, your oxidative stress. And
Yep.
basically, even older parents, that's tied in with oxidative stress. So you've got, um, I would not normally interrupt this, but I'm going to have to interrupt this. This is,
Go for it.
yeah, sorry. Hello, this is William Parker. Yes, sir. Yes, sir. Tomorrow morning would work. Uh, I'm yeah, I'll have to, I'm in a podcast now. So, this is Secretary of Health and Human Services. So,
Oh,
yes, yeah, we can do it now. Yeah, we can do it now. I need just 30 seconds to just tell this
take your
wonderful
time. Take your
gentleman that
time.
I need to take a little break. Let's see. The email address is let's just use my UNC email address. It's wparker1 at unc.edu. I'm sorry, sir. Could you repeat that? Uh, n- okay. Yeah, yes, sir. As soon as you're going to send me that link, and I'll just open the link, and we'll be set to go. Okay, thank you very much, sir. Yes, sir. All right, bye-bye. Yeah, so
Important call. I get it.
that was Secretary of Health and Human Services, so I need to take that, and I do apologize.
Yeah, no worries, no worries.
Yeah. I've been working on this for 10 years, so I don't want to pass up this chance to.
No, yeah, I get it. It makes sense.
Yeah. Thank you for your understanding.
Yeah, no worries. I mean, when I started so I didn't really know about this link at all until I started reading your stuff. But it's like you said earlier in our discussion when we were talking before about how one thing shifts and then a bunch of dots connect, because as soon as I read this, I had already known about acetaminophen and liver toxicity. I had known about glutathione depletion and the connection to oxidative stress and how toxic some of these metabolites were. But then when I read your stuff, I was like, oh, now it all makes sense. This is why you get onset of autism early in life. This is why you see it only in some kids and not others, even within families. This is why there's these genetic linkages between folate metabolism and oxidative stress pathways and all that stuff. And it just sort of all clicked into place.
Right. Everything clicks into place. The timing of it clicks into place.
Right. The apparent link to vaccines, because they often give young children Tylenol during a vaccine.
Yeah, it's not, the parents have never been crazy. That's not it. Like I said, Stephen Schultz, he figured it out, published the paper, and then it's just a matter of looking at, is this possible? Is it plausible? Even based on evidence in 2008, before the first animals were injected by Henrik Weiberg, I think he published that around 2014, and showed that it's absolutely a toxin for neurodevelopment. I mean, still there was plenty of evidence in 2008 saying, whoa, wait a minute, we should not have been using this drug without testing for brain development. It has, as you've gone into, so many effects on the developing brain. And just on even an adult brain, but obviously during development, that's when you've got to watch out.
Right. So let's talk a little bit more about the mechanics of what's going on here. So acetaminophen can be metabolized by a cytochrome oxidase enzyme. There's one major one in particular, and this will produce a toxic compound called NAPQ1, which can deplete NAPQI, which can deplete glutathione, which is a natural antioxidant in your body. What happens when that happens? What are some of the major effects in terms of the toxicity that's induced, in terms of what the oxidative stress is actually doing?
Well, so what happens is that, if you can't do this phase 2 metabolism and it gets shunted through the cytochrome P450 system and you produce the NAPQI, the quinonamine, that molecule by itself is super, super toxic. So normally what happens is glutathione, boop, it'll just stick to it. It'll become detoxified. Mm-hmm. And you burn up a molecule of glutathione. Yep. You literally burn it up. But if you don't have enough glutathione around, and I say enough, so this is all equilibrium reactions, right? Dynamic equilibrium reactions. So you're going to get a certain amount of that quinonamine that's just going to stick on the nearest protein, and we know it likes to stick for whatever reason on mitochondrial proteins and cause mitochondrial dysfunction. So the less, it's not an all or nothing, right? The less glutathione you have, the more of it is going to stick.
Right. You're going to get a little bit no matter what. But if you're depleted glutathione, you're going to get a lot.
Right. So it's all relative on how much damage. It depends on your dose of acetaminophen. It depends on how much oxidative stress you have. It depends on, which oxidative stress that depletes glutathione, right? And it depends on how much your body is capable of moving things, into safe pathways. If your folate is there, that's really helpful. If you have this folate receptor autoantibody that you can't get folate in, then you're going to get a lot more of the NAPQI. So, it's just all of these things going on simultaneously. So you've got all these different points along the pathway where things can put you at risk.
Mm-hmm, mm-hmm. So so this NAPQI, it's a highly reactive molecule. That's basically what toxins are. They're things that inappropriately or overreact. They damage proteins, they damage stuff in our cells that we need to work. And when that stuff breaks, you get cellular dysfunction, and then things don't develop properly or they don't work properly, and that's bad. If you've got a lot of natural antioxidants like glutathione, you can mitigate the production of these toxins to some extent. But if you're deficient, then you're really in trouble. And
Yeah,
so
and see, and also let me hasten to point out, Nick, some people are just have a genetic thing going, or they've got an autoimmune thing going, and so there's probably, we don't know, but there's probably nothing you can do in those cases,
right,
right?
right,
It's
right,
just if you get acetaminophen, boom, that's it. You're gonna have problems if you get it at the wrong time, especially right around birth.
right, right. So there's a natural spectrum of sensitivity to acetaminophen because of variation in all of these autoimmune pathways, metabolic pathways, glutathione, antioxidant pathways, et cetera, et cetera. So there's multiple different ways one might be more sensitive to acetaminophen. And then if you get acetaminophen at the right time, at the right dose, with the right sensitivities early in life, that's what you're saying.
Yeah, and
That's where the
I'm
rubber
just
meets the road.
yeah, there's a really cool paper that we published in a journal called Children, and we wrote this one for to make it understandable, to show that exactly what you the way you described it, a sensitivity profile over time. It's in a journal called Children. I'm the first author, and it starts out the dangers of acetaminophen. And that one has been viewed almost 34,000 times by folks. So it's really good. It has a little movie to go with it to explain. The publisher did a great job of providing a little explainer video. Really good. Recommends. And like I said, it's in a journal called Children. It starts out the dangers of acetaminophen. I'm the first author. Easy to find on the web.
When
Super
did
informative.
when did acetaminophen, when was it first used, and when did it start to become more widely used, especially in young children?
Yeah, so for practical intents and purposes, acetaminophen started to be used in 1886. So that's when drugs, phenacetin and acetaminophen were introduced in 1886, 1887, and those the body metabolizes into acetaminophen. So, and then of course autism was first described in the 20s and again in the 40s. But what really kicked it off was in about 1982, 83, when the medical community began to understand that aspirin may be associated with Reye syndrome. So we switched away from aspirin, went over to acetaminophen, because tragically studies in the 1960s and 1970s treating babies as just small adults, only looking at liver function, had decided that basically acetaminophen is safe for
Hmm.
babies. And
So,
then
so there was some thinking in the early 80s that aspirin might be causing issues when you gave it to young children, and therefore we should use something else. And then because of this presumption that babies are basically just little adults, the sort of default alternative to aspirin was acetaminophen.
that is correct. Yeah. And they did look pretty hard at, there were over 50 studies done, but they're all looking at liver function, which is what happens if you take too much acetaminophen as an adult.
Yeah.
Nobody ever, like you said, the first animal study with Henrik Viber, I think published in 2014, the first study, I mean, nobody even looked at it in a laboratory animal.
Wow.
So that was, it's extremely remarkable. And then there's so many smoking guns. This observation that acetaminophen affects social awareness in adults. And then one of the hallmarks of autism, that, and I very, very crudely explained those earlier, that a clinician would just say, oh, that was a criminal oversimplification. But it's the diagnosis is, it's the social awareness that is huge.
Mhm. So just summarize for people, like what would you say the strongest pieces of evidence are that acetaminophen is involved in the development of autism?
So I've never been asked that question.
Hmm.
And that's interesting. So we always say, well, no one piece of evidence by itself is worth really anything. There's probably 5 explanations for any one piece of evidence. There's great studies down in South America showing that there's no autism down there.
Hmm.
And they use the prevalence of Down syndrome as a baseline, which is a really clever way to do it, because you can't do a survey in a developing country like that. So it's a really beautiful study, but that's just one piece of evidence that shows you that Yep, but you don't have modern medicine, you don't have autism. And there's studies from Africa and Cuba suggesting the same thing, but they don't have Down syndrome as a baseline. So, but by itself, that evidence is worth nothing, right? It
Hmm.
just tells you something is causing autism, and it can't just be changing diagnostic criteria. So that that's a really good question. I don't know if I can think of any single. I'm running through it in my
But
head. I
no,
mean,
but
the
like I mean,
study.
other than the stuff we've talked about already, what are some of the what are some of the other lines of evidence here?
Let's see. There's a lot of metabolic. A lot of stuff in metabolism. There's studies in animals showing that it kills cortical neurons, which is not going to be good, and that makes sense because genetic polymorphisms with healing repair mechanisms are associated with autism. Let's see. There's a really interesting correlation between Orthodox Judaism and low autism, and Orthodox Jews tend not to use drugs
Hmm.
with circumcision, even with birthing practices. So they tend to have, and they, as I understand it, the Israeli government is trying to figure out why autism is associated with religion. It doesn't seem to be economic. It doesn't seem to be geographic. It's religion. And of course, the religious practices with Orthodox Judaism during labor and delivery and
Yeah.
circumcision are radically different.
And I suppose this also fits with why people always talk about how the Amish don't have autism and other things. And I don't actually, I guess I don't know, but I would assume they're not using Tylenol.
Right. I mean, they're not opposed to modern medicine, as I understand it. We've been really interested in studying the Amish, but it's easier to get the data from South America or from Cuba. I think they have 2 cases of autism reported in all of Cuba.
Yeah.
They vaccinate heavily, but they basically have a chronic shortage of all medication, so
Yeah.
uh, they don't have acetaminophen.
Yeah. But basically, like I'm looking at the paper, one of your papers that summarizes all the pieces of evidence here. Apparently, if you give acetaminophen to laboratory animals, they develop long-term brain damage and behavioral changes that look autism-like. Let's talk about this. So there's a well-known sex difference in autism. It's much more prevalent in males.
Right.
Apparently, acetaminophen affects a developing male brain more or differently than the female brain.
Yeah, so 2 different independent laboratories. That's really good. I've got my little cheat sheet over here in case there's any evidence I missed too. But yeah, that's the one I missed. So in laboratory animals, we know that males are much more susceptible to acetaminophen than females. And one of the first person to figure that out is the chair of pharmacology at the University of Maryland. So this is not, some small fry labs with assistant professors somewhere that are running these studies. Of course, not that being a big time professor means your research is good, but the point is that there's really good people doing research on this stuff, and 2 different groups have shown that the males, and I think now a third, but I haven't read that research. At least 2 different independent groups have shown that acetaminophen targets males specifically, and of course we know the ratio of autism in humans is heavily predominantly male.
So another thing here that's a little bit this is an interesting one. Male circumcision is associated with a dramatic increase in the risk for early onset autism. What do we think is going on there?
Yeah, so that's a study by guys named Frisch and Simonson, and basically Ann Bauer, who's in Boston, suggested that, hey, it looks like acetaminophen is really dangerous very early in life, so maybe circumcision early in life is bad because we give acetaminophen with it, even though acetaminophen is shown not to work for circumcision. Right. So, I mean, if you're in the kitchen and you accidentally cut your finger, you don't think, oh my gosh, I got to have a Tylenol. You want topical anesthetic, a Band-Aid. You don't need Tylenol for that, but they still are using Tylenol for circumcision. And when somebody said, okay, Anne might be right, and they actually did the study, they found a 2-fold increase in infantile autism associated with circumcision. There's been a follow-up study later that showed that circumcised males have a lot more issues with social
Hmm.
function, especially social withdrawal, than do uncircumcised males. So,
Yeah,
they.
but the idea here is basically simple, right? It's like a lot of male babies get circumcised, and one of the things that they probably just do is like, okay, give them something for the pain, and they just grab Tylenol sometimes.
Absolutely, and the babies love Tylenol. I mean, it tastes so sweet. I'm told by the pharmacist that most of the children who are chronically ill already have their favorite flavor of acetaminophen picked out.
Wow.
Yeah, it's so common. Yeah, in New Zealand, I think they call them lollies, like lollipops,
Just it
because
just
they're just
naturally tastes
so
has a sweet taste to it.
well, not naturally. No, they
Oh.
just put it in a syrup.
Oh, okay, I see.
Yeah, yeah.
Wow. And so here's another one that was interesting. So apparently, South Korea has an unexpectedly high prevalence of autism, and there's something interesting going on there that might connect the dots.
Yeah, so we put that on there, and we published a paper with the flagship journal for the Korean Academy of Pediatrics. But I that's the one that's so the overall picture is that we know that the manufacturing of acetaminophen got shut down in South Korea about 2012, and that the prevalence of autism was very, very high. But honestly, that one is the only one that's kind of speculative because there's a couple of issues. We don't know how long that problem had been
Mhm.
going
But
on.
what was the problem? Just so people know.
The problem was they were putting too much acetaminophen, too much active ingredient in their formula.
So basically, when you bought it, it had more than the label said.
It had more than the label said, precisely. Very well said. So the problems we have with that are, A, we don't know how long the problem had been going on. The problem would have had to been going on for a long time before to account for the data. And number two, we don't know how bad the problem was. The company said it was just a minor discrepancy with specifications, whereas the government said this is really dangerous. And if you look at the solubility of acetaminophen in so they add different stock solutions in to the final pediatric formula. So the most it could possibly be off by is probably a factor of two, maybe two and a half. That's
Mhm.
just based on solubility considerations for the different constituents that are in that formula. So, but maybe it was only zero point 0.2 or zero point 0.3, and we should have seen a decrease in autism later, but for whatever reason, that data is just not available. We can't find it anywhere. We've had other people looking for it that are really good at looking for that kind of data. So we're probably going to take that one off of our list just because we're not absolutely sure about it. We don't know if it's real or not.
Mhm.
The other ones that we have on the list we're super confident about. But this one, of course, it sounds like something fishy is going on, but we're not real sure.
Mhm. So let's go back to the development of metabolism, right? So it takes time for all of the stuff in the liver and the body to come online and to mature. So when acetaminophen is given to an animal perinatally early on in life, how is it so it's basically more of it going to the brain and going through oxidative metabolism up there because the cytochrome oxidase systems in the liver are not fully developed yet? Is that one of the ideas here?
Yeah, one of the ideas is that because your liver's not really doing its job when you're now, of course, now keep in mind, before you're born, before they clamp that umbilical cord or before the rat chews the umbilical cord in half, then, for humans, they clamp it, for rats chew it. But anyway, whatever. So the bottom line is, before that happens, the mother's liver is really good,
Mm-hmm.
much better than an average person's liver at metabolizing acetaminophen. The mother's liver sort of kicked into high gear to protect that fetus. But as soon as you clamp that, of course, then the only thing that should be getting through to the baby, now fetus, now become baby, is just breast milk, which is, of course, processed by the mother as well. So, in theory, if your liver's not doing its job, that's going to spread it out for different places. And the question is that cytochrome P452E1 present in the brain? And the answer is yes, it is. So if, your liver can't process it, and especially in these babies which have really bad, so all babies have deficient phase two safe, quote unquote, safe pathways. And there's some babies that are extra deficient because
Mm-hmm.
they're missing both the pathways.
Mm.
Then you're really going to have problems. Everything's going to go through the quinonamine pathway, and then if you have issues with folate, you have issues with,
Mm-hmm.
oxidative stress, other things on board.
Mm-hmm.
There's preservatives in the vitamin K that they give the baby. So there's a lot of things going on that the baby's body has to deal with that in a natural environment they wouldn't have to deal with.
Yeah. And apparently there's also an association between the levels of acetaminophen in the mother's cord blood and autism spectrum. Is that true?
Yeah, so that's a huge. If you just divide women into three groups based on how much acetaminophen was present at the time of birth,
Mm-hmm.
and the ratios of autism are 1, 2.2, and 3.6, which is that's remember just dividing them into three
Mm-hmm.
groups.
Mm-hmm. Just
This is
what is it like?
astounding.
Low acetaminophen, high acetaminophen, and none.
No, low, medium, and high because
Low,
it's
medium,
it's
high.
present. It's basically an everywhere chemical
Okay. Yeah.
now,
Yeah.
and your body can even make it from some microbial metabolites. So it's
Mm-hmm.
present in tiny amounts in everybody, depending on your analytical technique. But then, if they've just taken it, and there's been study, the the correlations between the analytical chemistry and what the mothers report is pretty good.
Mm-hmm.
But this study that we're talking about in cord blood, that's actual analytical chemistry. They just divide them in three groups. So if you run those calculations, so you got assume the bottom third of 1.0 is sort of normal,
Mm-hmm.
and then the middle range 2.2 and then 3.6. You just run the arithmetic, say, wow, about half of all autism could be just from the acetaminophen, and that is the worst time. If you throughout your whole life, from conception probably until death, the worst time in your life to be exposed to acetaminophen would be right when they clamp that umbilical cord, because that's when your liver's capacity to deal with that molecule is at its absolute lowest, because as soon as you're born, it's going to start getting better and better and better over the next few years. Yeah.
Wow. So the oxidative metabolism of acetaminophen produces NAPQI, which can cause damage. And it's going to cause damage in proportion to how much is created through that metabolic pathway and in proportion to what your natural antioxidant capacity is. So the more you produce, the more damage is going to be done. The lower your antioxidant capacity, the more damage is going to be done. And then I would assume also, just in parallel, the amount of oxidative stress you're under at the time that you're exposed to acetaminophen and you metabolize it that way, that's just going to leave you even maybe more prone to damage, because if something is causing just oxidative stress, generally speaking, and then on top of that, you got this NAPQI metabolite, that's just more. So what are the major events in early life that might induce oxidative stress in a young baby?
Well, of course, a lot of that is a lot of the susceptibility or the events. A lot of it's genetic, right? So it's the same with codeine, right? I mean, the 100% of codeine, that was just a certain one of those cytochromes, one of those oxidative cytochromes. If it's working too well, then you get an overdose of morphine. So it's the same deal with a lot of it is genetic. But say if you talk about an event.
What about let's call it an immune event? If your immune system was, say, stimulated, is that going to lead to oxidative stress?
Well, if it's stimulated by, say, an infection, yeah, that's going to lead to, and of course, a vaccination stimulates the immune system. A lot of babies with jaundice means that there's something going on. You're having problems already with your metabolic capacity, and that's associated with autism.
So if something triggers your immune system, there's going to be some oxidative stress that comes with that. And that would also be, let's say it gives you a fever. That would be exactly when a parent might be most likely to give the child something like Tylenol.
Right, exactly. Yep. Yeah, I mean, that's, it's a classic case. And in the original study that was done by Schultz, the scenario is your kid gets really sick. They take them to the doctor. Like, oh, you're behind on it. Well, first of all, you need some acetaminophen. They take them to the doctor. You get vaccinated because you're behind on your vaccines. So, and then you get told, well, you need to take some more acetaminophen. And then you go home, and then the child regresses as you keep giving them acetaminophen. So then what do you blame? Well, you don't blame the acetaminophen because you know that's safe, because that's what you've been told. You don't blame the cold because you know that colds or fevers don't cause autism. But the one thing left to blame is that the doctor injected some foreign substance into your child. So it is logical. It turns out, of course, it's tragically not right, but it does make sense from a logical perspective. So any of those kinds of events, probably teething, that especially if the kid is really stressed out and can't eat because something's going on, not being able to eat causes a lot of oxidative stress. So you got a lot of things going on. Ear infections will cause tremendous amount of oxidative stress. Right at the time of birth, probably just being born is probably actually the major hit. You probably don't need something, probably genetic factors combined with time of birth is probably enough there. But maybe at 18 months, you probably need some additional issues going on, would be my guess.
I want to go back to the issue of, too, like, in our lifetime, since you and I have been born, right? Tylenol, we've always had acetaminophen. It's just kind of second nature to a lot of people. It's just something that's in the cabinet. You can give it to reduce a fever, give it for some pain relief. A lot of people don't think about it much more than that. And you mentioned that it wasn't until, well into the 2000s that we even tested acetaminophen in animal development. We just kind of had this presumption that because people had been using it for so long, it must be innocuous, which turned out tragically to be very wrong. What does that start to make you think in terms of uh, how common it is that we make presumptions that these new inventions that we've made, things that were not around in traditional societies, that are not in, basically not around in the natural world, are we just too keen on assuming the best of these things? Should we just be more cautious in general about these inventions until they're very, very thoroughly tested?
Human nature is such that if I'm a parent and I think it's okay for me and I'm confident it's okay and I've used it repeatedly, I probably think it's okay for my child. And that's what happened with codeine, right?
Mm-hmm.
It was on the market for almost 200 years before it was banned in 2017 when they figured out it was killing children. So, but it's only banned age 12 below, not for adults. It's fine still for adults. So, it's hard to know. There's so many drugs that made it through. They were grandfathered in by the FDA. And I think, and what I'm told, and I think this is correct, the only one left for children is acetaminophen. I think that's true. So basically, this is, and I was in a meeting today with some very high level individuals trying to figure out, well, what do we do instead of this? And there's basically we don't have any tested alternatives. And of course, a lot of the reasons why we're using acetaminophen, you don't need it for teething. You don't need it for routine fevers. You don't need it for most things that were the average childhood aches and pains, because those are simply not dangerous.
Mm-hmm.
But if a woman's in her third trimester and has a migraine headache, and the main thing there is the mother needs to know before she gets pregnant, look, if you're prone to get migraines, this drug can do this. So you need to know in advance, this is what the deal is here. So you maybe try to figure out a way to manage your migraine headaches before you get pregnant. Mm-hmm. Would be the idea, which is, that's not an easy thing to tell somebody, but it's probably what they would be thankful to hear, because they don't want to put a child at risk for neurodevelopment. And
I don't know how many labs there are in the US and in the world studying autism at some level, probably hundreds and hundreds of labs studying this in some capacity. What is the general view in the research world among scientists about the acetaminophen autism connection? Is this widely accepted? Do some people not believe it? Give us a lay of the land there.
Yeah, that's a great question. Great question. And I'm sorry I didn't have a better answer to your question about like how generalized is this? So we assume things are okay for children, but plastics, pesticides, there's a lot of stuff out there that we don't even think are safe for adults. So but we won't even talk about that. So to your question, let's see. I got sidetracked. You had to repeat the question.
So how widespread in the research community, broadly speaking?
Right. Okay, so if you look at the body of literature on autism, there's about 85,000 papers in the literature.
Mm-hmm.
So if you cross-link that with cause, you're going to only see about 35,000 that have something to do maybe with cause and autism. But there's only about 160 or so that have to do with acetaminophen and autism. And if you break that down, there's only about 70 that have anything to do with is acetaminophen dangerous, and only 10 of those are actually going to say it's dangerous. So almost nobody's aware of this. So the consensus opinion is that it's what we said earlier, that it's this complex mix of stuff. And it's a confusion of association with causation, right? They think, well, since it's associated with all these genes, 800 genes or whatever it is, plus a bunch of other things, environmental, epigenetic things, then it must be that's causing it. Right? And of course, what we know now is that, I say we, but not my colleagues, but we, is that all of this stuff is just creating susceptibility to acetaminophen. And then if only 5% of people were using acetaminophen, it would be obvious. And everybody would see it like, oh, this is what the common denominator is. But since almost everybody's using acetaminophen, it's like our example of cigarette smoking before,
right?
Then it kind of washes out of the equation. We've done mathematical modeling of this and shown that, if you have heavy use of acetaminophen, it'll wash out of the equation when they do this kind of math that they're doing on it.
Mm-hmm. have there been animal studies where they very clearly they can give half the mice acetaminophen at a high dose, or maybe a third at a high dose, a third at a low dose, and third none at all, and you see very clear neurodevelopmental and behavioral effects?
I mean, the first animal studies that were done showed huge effects just with two doses at 30 milligram per kilogram, and babies can get up to 40 milligram per kilogram. So it's with suppository. So this is not a huge dose of acetaminophen, and two doses before the age of 10 days cause permanent inability to learn how to run a maze to find food. And normally mice are really good at that. They can run a maze to find food. That's sort of what they do for a living. Even in laboratory, mice can do it. It takes them only 2 days of practice, and they're awesome at it. They almost make no mistakes. They run the maze, no mistakes. They get their food, they're done. Whereas if they've been exposed to just these two little doses of acetaminophen, now one dose won't do it. And if you wait long after the age of 10 days, then it won't work either.
It's got to be a sufficiently high dose in the right window of development.
That's correct. Yeah.
But that's a feature of exactly what we need to find. Like clearly there's some kind of developmental window and sensitivity here. So that fits.
Yep. It's, yeah. And we have a pretty good idea. I get asked, okay, if we're going to make a law and we're going to stop this, and obviously labor and delivery is your first target. Don't use it. Tell the obstetricians don't use it. And then the pediatricians and caregivers know don't use it before the age of 3. Yeah. And then probably age 4 and 5 is kind of squishy, but that but pregnancy, especially later in pregnancy, is probably worse than age 4 or 5. So, you've got, but we don't, though, that's where the more detail we get into, the less certainty we have.
But like today or in the very near future, if more people were to become sensitive to the very strong potential, it seems, that acetaminophen might be contributing to neurodevelopmental abnormalities like autism. And today or next week or next month, a bunch of people started conscientiously saying, no acetaminophen to the doctor when they're giving birth, no acetaminophen for my kids before the age of 3. Then several years from now, we might be able to see a clear signal of this.
Yeah, it would take about 18 months. So just hypothetically, let's suppose the Secretary of Health and Human Services announced that this is bad, this is, and this is what's causing autism, and hypothetically he did it next month in September, then you would see a profound regression. The median time to regression is 18 months, so you would definitely see the data showing up. You would have to do
within a couple
monitoring. Years. But it's 18 months, so a year and a half probably you'd see it.
And so let's talk about that regressive form of autism a little bit more. Let's define exactly what that is. So when you say regressive autism, walk us through concretely what that looks like when a parent experiences it. Is it that their child seems normal for a year or two and then they almost develop backwards?
Yeah, that's it exactly. So you've got two basic, you've got autism, a whole spectrum. But some children seem to have it from birth, although now we think that a lot of those were induced right at birth. They were okay. They were okay 2 hours before birth, and then they're not okay 2 days after birth. But that's called infantile autism. And the other kind of autism is where the parents see some development.
Right. Everything seems normal, and then...
Well, so not necessarily normal. Remember, these kids... They may have already been exposed to acetaminophen. They may already have some damage done, and a lot of them probably have a lot of oxidative stress or immune. They probably have immune system problems, which makes them susceptible to acetaminophen-induced injury. Right. So they might not necessarily look normal, but they're still developing. And then when the big injury happens, when they get exposed to that drug, then they regress.
There's an inflection point. Something clearly changes.
Yeah, they lose developmental milestones is technically the way they say it.
I see. Okay, so it is truly regressive. Like they achieve some milestones, maybe they start babbling, they start walking, whatever, but then they lose those abilities.
Yeah, and a lot of them do seem perfectly normal to the parents, and then all of a sudden, whoa, this is not right. They are not okay. But they don't necessarily have to be normal. They just have to be. They could be developmentally delayed, but they're still progressing, and then they'll lose those developments.
Right. Interesting. And again, if we come back to the vaccine controversy on this, I don't know that, maybe you know the numbers here, but I would just imagine, right? You're going in for a shot. The shot hurts. Maybe the shot gives you a little bit of a mild fever because of what it's doing to the immune system. That's exactly the circumstance when a parent might be most likely to give their child Tylenol.
Right. Again, the scenario is if the kid's sick and you take him to the doctor and then he's behind on his
Right,
vaccines, that's the
right,
worst case scenario, right? And
right.
everybody sort of knows it's not a good idea to give a bunch of vaccination when a child is sick, but since everybody's thinking this whole process is so safe, they don't worry about it too much.
Wow. Yeah, and it's just amazing that, I mean, give me that statistic again. When was it that we first started looking at the developmental effects of acetaminophen in animals? It was 2000 something.
Yeah, 2014. Yeah, that was Henrik Viberg.
Wow. So it's like we went all that time and no one ever looked. We just kind of presumed
Yeah.
it was okay.
There's an interesting study from the 1980s showing that you can kill a neonatal animal with so much acetaminophen. If you just give a huge dose, you can kill them, but their livers are fine. So, that was a clue,
Right.
right? A really
It's not
big
inducing
clue.
liver damage to kill them. It's doing something else.
Something else, but we don't know what it is. So, yeah.
Wow. So one thing let's just talk about acetaminophen separate from autism for a minute. My understanding is that there's quite a number of adults every single year that go into the hospital because they've got acute liver toxicity because they took a little too much acetaminophen. Can you just talk about liver toxicity and adult use of acetaminophen?
Yeah, so adult, earlier this morning I had a diet soda, right? And diet sodas aren't healthy, they're not safe, but it's the risk is so low. So every week in the US alone, 40 million people take Tylenol or acetaminophen. Some, adults tend to take generic, they tend to give their babies the brand name, and only 2 people die.
Mm-hmm.
So it's probably safer than the diet soda I had this morning, just in terms of,
Yeah.
relative impact.
Yeah.
But yeah, if you
Millions and
look at
millions of adults are taking it every week, but a tiny, tiny fraction have a problem that requires them to go into the hospital.
yeah, almost no, your chances of getting killed in a car accident are way greater than that. Whereas if you look at how many people have autism right now, it's 1 in 31,
Right,
right? It's
right, right.
population. So 3% is a lot different
Mm.
than 1 in 20 million.
But I want to give people a sense for the antioxidant side of this. So if an adult overdoses on acetaminophen and they've got acute liver toxicity, what is the antidote for that?
Right. So there's 2 situations where acetaminophen is toxic in adults, and one is an overdose, and that's the most common where people are intentionally, and you have to, I mean, it takes a lot of that to overdose. You got to take about 30 pills, and it's a horrible way to die. It's not good because your liver fails, and it's just all bad. But if you get to it in time, you can take a derivative or a precursor for glutathione, which we talked about before. The one that's most commonly used is N-acetylcysteine. You could use cysteine, but it's sort of smellier and more disgusting because you can smell the sulfur more. And then your body converts that to cysteine, then to glutathione, and then that helps you deal with all that quinonamine
Mhm.
that's being churned out. And it's a massive dose,
Yeah.
N-acetylcysteine that's taken for that. And it works pretty well as long as you catch it right away. But if the damage has already been done in the liver, then
Right, right,
yeah, it's too
right.
late. And the other condition that is really bad is chronic alcohol consumption.
Mm.
So chronic alcohol consumption really ramps up that enzyme that makes the quinonamine. It ramps up the CYP2E1. And
Mm.
there's so many parallels between fetal alcohol
I
spectrum
see.
disorder and autism spectrum disorder, right? It's
I see.
and part of that is they're tied in even in adults. If
So,
you consume a lot of alcohol,
yeah. So it sounds like it would be, I've personally witnessed this multiple times in my life. You're out partying one night, people are drinking, they're anticipating the hangover the next morning, so they pop some Tylenol the night before. That sounds like it's a really bad idea.
it's a really bad idea. People have died from that, but again, it's not common.
Mhm.
So, and there's a mother online that we've talked to a lot and that helps us broadcast our stuff. And her 20-year-old kid in college, that's what killed her. I mean,
Yeah,
just
yeah,
from one day to the next, because that was her habit.
yeah.
She would drink, take
Right.
Tylenol, and then one
But also,
day,
but even if you're not taking like a mega dose or anything, just over time, year after year, decade after decade, that's just going
right,
to you're going to accumulate more oxidative damage if you're in the habit of combining those types of things.
absolutely, and that puts you much more at risk. So that, and what the drug manufacturers say, well, those 2 people that die every week, those they had pre-existing conditions, which is probably true. There was something going on there, maybe chronic alcohol consumption. And we're not talking about intentional overdoses. That's separate. The ratio of getting liver injury intentionally versus just not just taking average doses for prolonged periods of time and getting hurt that way, it's probably about 50-50 just in terms of the number of people that get hurt.
Yeah, and so just to say it out loud and just to be direct about it, your opinion, based on your expertise, is that we should not be giving acetaminophen to pregnant women. We should not be giving it around the time of birth. We shouldn't be giving it for the first few years of life.
Yeah, so as a scientist, we can say it's dangerous. This is what it does. It causes autism spectrum disorder, probably ADHD, maybe developmental delays, although maybe not. Anyway, the bottom line is that, and that's affecting, if you count ADHD in there, then you're affected. In ADHD, we normally don't deal a lot with that because it's a little bit, even diagnosing that is kind of squishy. But the bottom line is it's affecting a lot of children. So as a policymaker, when I talk with policymakers, this is what you should do. Absolutely no question about it. You should issue, the FDA should issue this thing called a contraindication. You shouldn't be using this drug during a certain time frame. But when it comes to personal medical advice, we can't give that. So it's a weird situation we have where we can't tell the average mom what to do. We can only tell her, this is what we're recommending for the regulatory agencies to do, and this is what we know the drug does based on, and I say no, which means concluded without a reasonable doubt. This is what we know the drug does. So then you have to make up your own mind. Because we're not medical professionals, we can't tell the individual what to do, but we have published our recommendations for the
well, let's say so let's just say hypothetically you've got a 1 or 2 year old at home, and like any other 1 or 2 year old, they're going to have a fever from time to time. They're going to be in pain. They're going to bump their head. Stuff's going to happen where a normal person might want to reach for some Tylenol or something to bring some relief to their child. Perfectly natural. You don't want them to be in pain. You don't want them to have a fever. You don't want them to suffer. You don't want them to irritate you with their crying. Like, this is normal stuff. What would you do in a situation like that instead of Tylenol?
Well, so I understand the question. It's a really good question, but answering that question it's related legally to giving medical advice. What I can say is that in terms of standard aches and pains that you're describing, there's no proven long-term benefit in the medical literature for giving that drug, number one. And number two, the drug is dangerous for neurodevelopment. So then the parent has to figure that out. So I'm not even allowed to tell, I can tell my friends what I would do. I can even tell my friends what they should do because they're my friends, but I'm not allowed in a public way to even say, well, this is what I would do, because that's too close to giving medical advice.
Got it.
Yeah, but I can give them the appropriate information, and then they can make an informed decision. And I think one of the people that I've been working with public outreach is their big deal, and they're really good at this, is emergency preparedness. And they've been working on, and apparently in that field of emergency preparedness, the plan is key. You do not want to be making that decision when the kid is screaming and crying and it's an emergency. You want to have a plan worked out in advance based on all the information you have available, so you don't do something you'll regret. And so that's our number one recommendation, is learn everything you need to know before your kid gets sick, preferably before you get pregnant, and then make a plan and follow that plan that's based on everything, all the information that you can glean. And that's the safest thing to do.
But it sounds like in your expert opinion, the link between acetaminophen use in early life and autism is sufficiently strong that if new policies are made, if people are just more aware and they stop using acetaminophen during pregnancy, during birth, and in early life, that we should see a very strong decrease in things like the rates of autism and even ADHD in the coming years?
Yeah, our best guess is probably around 94 to 96% decrease. And then what we think will happen then is, okay, you've got this residual left over. And so then we'll have to sort it out. Okay, autism as we know it was really acetaminophen-induced neurodevelopmental injury. And then we've got these other things which sort of bend in there. And, well, let's figure out what they are. They're something different. And so then we'll refine the diagnostic criteria and based on the causal it's not clear that
Yeah.
any genetic condition can really
Right.
cause
Yeah.
autism. Maybe it
But
can, or maybe
yeah.
it's just certain genetics put you at risk for autism.
Yeah. But if you're right, we're not talking about a subtle effect. It's not like a 5% decrease. We're going to see a big effect, and we'll see signal pretty soon.
Yeah, I mean, if it's only 5%, then I mean that doesn't that's I don't that's just not possible based on available evidence.
Mm-hmm.
So yeah, we should see it should take about 18 months to see it really drop off, and then it should take about another year or two to see it just plummet
Hmm.
down to very, very low levels.
Hmm. And so what I mean, is there anything else that we're missing that's major from this discussion, or do you feel like we've covered all the main points here?
Well, I think the main thing that we think about a lot is, well, what are the counter arguments for this?
Yeah,
You know,
yeah, yeah.
we talked about one earlier on, and we can tell it's not just changing diagnostic criteria. Those really haven't changed. You know, people blame that, but they really haven't changed. I mean, it's still basically what Leo Kanner described in 1943. It's still really the same thing. So they did make it a little bit more selective at one point, but that it still went up and up and up. So it's not that, and then we can look down in South America and use Down syndrome as a baseline and say it's something to do with our society. It is, as you pointed out really nicely to your audience earlier. It's there's a combination of increasing awareness, which we expect as something becomes more and more common. So there's that, but then there's I think dealing with this idea that there's this study that came out and said no, it's from Drexel University, really reliable, and it says no, it's safe. But and the problem is that a mistake will go around the world 15 times before
Well,
the
you're saying there's a
correction comes
study
around.
that said acetaminophen is safe.
Yeah, study saying acetaminophen is safe, and it's like it's from Drexel University. It's a really good study, but then we publish. It takes time. It takes months to publish the study demonstrating that they were incorrect, that they made mathematical errors. And the only thing they proved that acetaminophen is safe if you have no risk factors, and we already know that. So
Yeah, yeah,
that's a problem. Is that when I talk to doctors a lot, they'll say, "Well, what about this study?" And then like, "Okay, all right, it got a lot of press. The
yeah,
doctors grabbed onto it
yeah.
because
You're not saying that everyone who's ever taken any acetaminophen early in life gets autism. You're saying if they take a sufficient dose at the right developmental time point, if they have certain susceptibilities.
right." And then those studies don't get that. Those
Mm-hmm.
studies basically cancel out the contribution of susceptibility. And we've mathematically modeled this and showed how it worked. We published the mathematical modeling. This is a big problem that we have, is that people are trusting studies that are flawed, and they're in the literature and they have a lot of press and they're from reputable institutions. And there was just one that came out of Harvard which has major flaws in it. And I've sent a comment to the journal, which was rejected twice, and they just said, "Oh, this is not a topic that we normally cover." I got a form letter,
Mm-hmm. Mm-hmm.
right? But I'm talking about a paper you just published that didn't
Right.
understand the research that we did. So there's in science
People, yeah,
sometimes
you should never
errors.
assume that just because something is published, it's believable.
Right? Yeah, which makes it tough because and the people publishing this, they're epidemiologists, they're very smart, but I work with neuroscientists, toxicologists, pharmacologists, so we can put all this data together
Mm-hmm.
and sort everything out and look
Mm-hmm.
at it. And so if you're an epidemiologist and you look at your data, it's possible that it's A or B or C or D, but if you look at the big picture, nope, it has to be A. But if you're only looking at one kind of data, it could be all these different things, and depending on the assumption you make, you might decide the wrong thing.
Mm-hmm.
So that's the bottom line. That's the difficult part for us as scientists, is dealing with a consensus bias. I mean, I submitted our work to a major journal, and the number one criticism I got was a formal statement of the consensus bias, which is that, well, this is not the accepted paradigm.
Right.
Yeah, that's not a reason to reject a paper, right? You
Right.
should,
Right.
if it's what everybody else is saying, why even bother to publish the
Yeah.
paper?
And I
Right? The
mean, perhaps
question,
perhaps it's worth pointing out that if the quote unquote consensus paradigm is that the cause of X is this complex multifactorial thing. To the extent that's true, you can keep studying more and more and more and more forever and ever and ever, and keep the whole keep the whole train going. To the extent that a problem is solved, the party is over in some sense.
Yeah, and the thing about autism is it looks like a specific interaction with a specific something, right? Because it has these hallmark features that are affecting social awareness. As I said, acetaminophen affects social awareness in adults too. And it went from essentially zero, looking at countries without modern medicine using Down syndrome as a baseline, to 3% of the whole population right now. And these hallmarks, right? This is the key. It doesn't look like 50 different things. If you look at mercury poisoning versus lead poisoning, they look different.
Right.
Right. So it looks like it's specific based on the diagnostic criteria. So it doesn't make sense that 50 different things can cause it.
Mm-hmm. It's a specific thing, but it's a specific thing interacting with a pre-existing susceptibility within the right developmental time window.
Right. And you get the spectrum based on when you get exposed and how much other susceptibility factors you have.
Right. Interesting. So, well, yeah, this is very interesting because, again, if what you're saying is true and all of these things make sense and fit together, and people start behaving differently with respect to early life exposure to acetaminophen, we will see a clear change in the trajectory of autism and other things, apparently, within the next couple of years.
Yeah, my guess would be ADHD. So what I'm told by clinicians is half of ADHD is probably, just children that don't want to behave, and half of it is really a kind of disorder. But that's, who really knows, right? But the bottom line is I think you'll see a big drop off in that as well. But that's just a guess. What I'm saying about autism, we have this quote unquote certainty without reasonable doubt. Whereas ADHD is like, well, it makes sense. There's a lot of indications that Asperger's and ADHD are sort of part of that injury spectrum. Mm-hmm. So you should see, the guess would be that those will all drop off, but we're super confident about the autism spectrum disorder.
Yeah. Are there any final thoughts you want to leave people with, or anything you want to reiterate on this subject for people?
Yeah, absolutely. So back in the day, we discovered the function of the human appendix, right? So the main thing we had to tell people was, look, just because we know it has a function, if you get your appendix is hurting, you need to go to the doctor, get it taken out so you don't die. So by the same token, if your child has a headache and it's not just, from bumping their head, or even especially maybe if it is from bumping their head, whatever, you need to go see the doctor, because especially if they have some conditions, it's not just normal teething, it's just not a normal fever from something they caught at daycare, right? It could be something really dangerous. So we're not saying stay away from the doctor, don't go see your doctor, because that could be very, very dangerous. Most fevers are it's natural part of your immune response. You probably shouldn't suppress it, because it's, you're basically immunosuppressing your child. But it could be a sign, especially if it's a fever above normal in duration or in temperature, that something else is wrong. It could be an underlying problem, and you got to go see the doctor. Don't just avoid the doctor on that.
All right. Well, William Parker, thank you again for joining me. This was fascinating stuff to read about and talk about you with. And I look forward to seeing some announcements and some changes on this in the near future.
Yeah, I believe you will see some changes in the very, very near future, Nick. Thank you. Thank you very much.
Visit mindandmatter.substack.com to find all of my content. Hey everyone, I want to take just a minute to tell you about a really cool health monitoring device I've been using called Lumen. It's a handheld, pocket-sized device with a sleek design. The Lumen device measures CO2 levels in your breath, which allows their technology to determine the extent to which your body is burning fats versus carbohydrates. Lumen helps improve your metabolic flexibility, your body's efficiency in shifting between using fats and carbs for energy. I use this device device in the morning or before bed or after meals or after workouts to track my metabolism. With just a couple weeks of use, I learned a lot about which foods were causing my body to burn mostly fat, mostly carbs, or both, as well as how long I needed to fast and how hard I needed to exercise to promote fat burning. Being able to track whether your body is burning fat versus carbs will help you figure out how your body responds to your lifestyle and whether or not your weight loss and fitness strategies are actually working. Lumen is great for anyone looking to optimize their health for either weight loss or athletic performance. Their easy-to-use app allows you to track your results together with what you're eating and how you're exercising, and it syncs with other devices like the Apple Watch. Click the link in the episode description to learn more and use the code MINDMATTER, MINDMATTER, to get 10% off your Lumen device today. That's on top of the site-wide sale they are currently running, and the Lumen device is eligible to be paid for with FSA and HSA health accounts. Check out the link in the episode description for more info.